Majid is a passionate software developer with years of developing and architecting complex web and mobile applications. He's passionate about web platform, especially Flutter, Internet of Things, PWA, and performance. Majid loves sharing his knowledge with the community by writing and speaking, contributing to open source and organizing meetups and events. And Majid is also the award-winning author of Progressive Web App with Angular book by Apress and Progressive Web App video course by PacktPub and Udemy. And also, Majid is co-organizer of few mobile and web meetups in Norway, as well as Nordic conferences for mobile and Angular, Mobile Era, and ngVikings. So no information about your love to cats and dogs and everything else. But you can share about it if you want, yeah.
Yeah, sure. But can you hear me?
Yes, I hear you, and I assume that everybody hears it.
Okay, perfect. So should we start?
Yeah, let's start.
All right.
It's your show.
So I don't see actually how many attendees right now on the call. So, but I want to welcome everyone and say
40 people are watching.
Wow, it's 40 people. It's amazing. So you're all amazing watching us right now. So fantastic. Thank you for choosing us and particularly my talk today and spending time with me for maybe half an hour or so. So I'm going to talk about parallel computing and different possibilities on the browsers these days. I mean, in particular, actually, because the previous talk was related to React, I actually made most of the examples with React. So I guess that would be like a transition between the previous talk to this talk. For you that you already actually watched the previous talk for middlewares, you may even want to use some of the techniques from my talk when you're implementing your middleware. So you will find them in a bit. So, but I'm pretty sure that all of you have seen this probably screen. So usually in the conferences, I ask and people raise the hands and like 90%, 95%, like maybe even 100%, they say, yes, we've seen. And you see that this is like what we are building for our customer, that the unresponsive page is the consequence of some of the things that we can do, but we may not take them into account before deploying to our customer. So this is the reason that I'm gonna give this talk today. So we're gonna try to avoid these kind of screens as much as possible. So the reason behind it is that it makes not only like your customer, even yourself as a developer frustrated. So like if the customer is not happy, they come back to you, and then you're not happy at the end of the day. So what I'm gonna explain and explore today is, well, first let's go through some basics about parallel computing and versus concurrency, what are these? And then I'm gonna go through web workers, WebAssembly, Worklets, and service worker. So it's gonna be interesting. You may have some question right away right now, like why service worker? So what is Worklets? So we're gonna get to it. We're gonna get to it very soon. But before I start, I like to actually have a disclaimer here: is that whatever you hear from me today is so practical, no theory, no boring stuff. So after the talk, or maybe during the talk, I don't see you. You may even implement or start using some of these techniques right away. So this is the intention of giving this talk to you. So I want you to be ready to start using. So no theory behind it. So let me just introduce myself. My name is Majid. I was introduced already, but I'm based in Oslo. I am a passionate developer like you, particularly focusing on JavaScript and these days Flutter and IoT. And in my spare time, I organizing a few meetups and conferences in Nordics and especially in Norway. I also wrote a book about progressive web app, in particular with Angular. So let's move on to the parallel computing definition. So when we are talking about parallel computing, you may know that we are referring to multiple entities that they are doing multiple tasks or working on the same task at the same time. So, but when we are talking about concurrency, so the pictures are pretty much self-explanatory, right? We are talking about one entity that is doing several tasks. So, but what is it? What is this related to? Like, how can I make a connection between that and JavaScript? So you know that JavaScript runs in a single thread, right? So you share the thread between your JavaScript and DOM and etc. You know, and when we are talking about thread, we are not talking about CPU core. So don't get confused. But in JavaScript browser, actually in browser, we have event queue. This is how it works. So even though we have one thread, we have a queue of events, and these events are different things. It could be JavaScript code, it could be your click on the mouse, it could be other stuff, right? So everything is like an event, and it goes to the queue, and it works. But okay, so as long as the events are pretty quick and they done and they go away from the queue, everything is fine. But what if we have an event that takes a little bit longer? Of course, and obviously, as you see in this slide, the other events need to wait until this event is done, right? We're gonna fix this issue. We're gonna go through this issue today and with different possibilities in browser to see how we can fix it. So the first option that I'm gonna talk about is web workers. Web workers, I'm pretty sure, I cannot see, but I'm pretty sure like 95% or maybe 100% of you have heard about web workers. And you may even use them. But it's very underutilized. We don't use web workers quite often. But what are the web workers? Actually, what they do is they spawn another instance of JavaScript and they run it in a different thread, in worker thread. And they have some characteristics, like you need to communicate from main thread to this worker thread via messaging, post messaging system. And probably this is a bottleneck of using these workers. Okay, let's have a look at it. When we have this queue, so we can send one of these from our browser queue, and we can send one of these events to the worker thread, and worker thread also has its own queue. And then once via the messaging system, and once that is done, it will be back to the queue in the browser again. But this resembles actually concurrency, right? Of course. But the thing is that you may ask, where is the task parallelism? Well, you're talking about parallel computing, but you said that this is like concurrency. But yeah, of course, this is a concurrency. But right now, these days, many computers, many servers, you know, many laptops, they have different cores. They have 8 cores, 6 cores, 4, you know, and nothing stops browser that runs this thread in a different cores. But the thing is that we as a front-end developer, let's say, who work with front-end application, we don't know. The thing is that we don't know. So this is that something a browser and the system is making a decision about it, but it may happen. So you know that even though we don't know, that doesn't mean it doesn't run in parallel, like in different cores. Good. So, but then what is the use cases of these web workers? Well, Usually for web workers, we're gonna do most of the execution or heavy computation to these. We want to hold of these to the workers thread. So like if you have any audio video processing, if you have any image processing or encoding, for instance, these are the good example of sending these execution to the thread, worker thread. But let's have a look at the traditional way of web worker and why we don't use it. I think that is the problem. So we have main thread, our browser, and we have worker. And then how it works is that you need to send a message, right? In code, if I want to show you, is if you instantiate a worker with your worker JavaScript file, then you can actually, if you see in my code right now, you can actually see worker.post message, which I'm sending a message, which is an object right now, obviously, has action and payload. All right, so how does it look in my worker? So in my worker, I need to listen to the message that are coming, right? So I listen to the message, then I get my data from the message, and in the data, it's the exact message that I'm sending, like the data that I'm sending is like an object with action and payload, right? So then, for instance, in this case, I want to power this number to and then once I'm done, I'm sending back this message with the data to the main thread again. And on the main thread, we're gonna have on message in the worker, and then you need to listen to the message that are coming, and then, you know, you get the point, right? It's, well, probably that is the reason we are not using web workers. They are so powerful, but because of the way that it works, so many of us like may not like to use them. So, but there should be a better option probably. Like, what if when I instantiate the worker, I immediately get access to the method that I have in the worker, and then run it and get immediately the response, or like after the execution is done, I'm getting the response, right? That would be awesome. So here is where I'm going to introduce you Comlink. It's a library from Surma, a developer advocate at Google. It's a pretty awesome library to simplify working with web workers. And let's see how it works. So when you, let's say you're importing your Comlink and etc., and then when you are instantiating your worker, so that is similar to how you instantiate the worker. That's fine, but then what you need to do, you need to actually wrap your worker with a proxy with Comlink. You need to wrap it, right? Once you wrap it, then what Comlink does, it just makes it so simple. It just promisify your services, and then now you get access to the method on that service or that worker as a promise. So you can immediately call this service. This is fantastic. So now you can immediately say, hey, my worker.power2, and then it's a promise, wait for it, and then you have the response. So no post messaging, nothing here, you know? So let's move on to the worker part of it. And so how does it work? So once you import the script for necessary function that needs to be imported, then you have your service. For instance, here I define it as an object, which has two method, power2 and increment, and that does something, right? So you can define your method, you can define your your function, or however you want to do it, and then I expose this object. That's how I expose it by Comlink, and then I get it access to the main thread. So let's have a look at it in React. If you use React hook or class-based, doesn't matter. The point here is that when I want to instantiate, I have an example here. The example is that I have a list of 3,000. This is deliberately created. I have a list of 3,000 users, which I'm going to sort based on some criteria, right? What I'm gonna do for this sorting, I'm gonna just move this sorting to worker, and I'm gonna show you why I want to do that. So, but I'm gonna use Comlink. So I wrap my worker here, and then so my worker is ready at this stage when the component is mounted. All right, so now I have one function for sorting ascending, and what it does is, you see in this example, it just calls sort function in my worker and send the list of users, and then as a result it gets a sorted list of users, and then once it's back I set the state and then DOM is changing, right? So in my worker, technically I have now one function sort ascending, let's say. And then what I'm going to do, this is on purpose. I didn't optimize this. I want this to take as much as possible time. So that's why I have like very unoptimized version of this code. So then I have the sorting version of this function or this array. And then, all right, I expose it. Let's have a look at it right now in example. Like how does it work? If you see in my example right now, I hope that you see it smoothly, because I don't know how does it work in streaming. But if you see it here, I have a list. And if I press on descending, the green button, descending without web worker, my animation stops working. And then once the array is back, sorted back, then start working again. But the reason is that there is no worker, and then the event that I'm clicking and to do something in my browser, it takes a long time. So that's why everything is just hold until that event is done. But if I send it back to web worker, then you see my animation is working very smoothly. And then once the result is back, I get it and change the DOM. So you see that how is going to be easy to use this library in your application and give your user a little bit more better experience, let's say. So let's talk about WebAssembly. Of course, when I'm talking about WebAssembly, I'm pretty sure all of you have heard about that, right? So WebAssembly gives us like this ability to write different languages or run different languages and compile them to WebAssembly or WASM and run it in browser. This is fantastic. This is great already. But the thing is that as soon as we're talking about WebAssembly, we as a web or JavaScript developer, we usually think of, oh, now we need to deal with C and probably Rust. There is nothing wrong with these languages, right? I love all of them. All of them are good, but we don't have time to just, learn all of them and do something, for instance, for a project. If you have time, just feel free to learn it. But, it would be very, very easier if we had some option that we already been familiar with, right? So here is where I'm going to actually introduce you assembly script. Assembly script actually compiles a strict subset of TypeScript to WebAssembly. So WebAssembly types are tied to this assembly script, and then you write your TypeScript if you are familiar with that, and then you're good to go. You can write WebAssembly. That's perfect. So let's have a look at it. Like I said, I'm not going to go through theory. How does it work? So you can go and read it on documentation, but let's see it in practice, like how it really works. So the initialization of the assembly script is very easy. So you just need to download it, and then you just say, technically, you just need to install it from npm, and then you just say npx as init and the folder that you are going to create this project. It's going to create some folders and files for you on the fly. So you will see assembly folder, you will see build and index.js and package.json. So pretty understandable. Like, of course, the index.js file is the file that, or assembly index.tx file is the file that I'm going to write my TypeScript file functions. So let's have a look at it. For example, here, I want to actually introduce a Fibonacci function. So, but I want to do it, well, that might not be a very good example for using WebAssembly, but that's a very simple example to show you how easy it is to get it started with. So I want to actually move on my Fibonacci function to WebAssembly. You see that here, I just simply use TypeScript functions and TypeScript annotation. But as you see here, the typing system is a bit different. So I don't have here, like, for instance, those types that I usually have in TypeScript. I have instead integer 32 or integer 46 or different assembly TypeScript. So these are the types that you can go through it and learn from it. So, but if you back to the function, though, this is a very simple function. Again, no optimization, no memorization, because I want to do it as long as it's possible to run this function. So I want to also mention here briefly that take into account that still you may need to deal with memory. It's not that hard in assembly script, but you may need to do that. But the good news is that they're working on it, and then probably in a few next releases, we will see that this is also gone and everything is automatic for us as a JavaScript developer. We don't even need to think about memory allocation anymore. That is also going to be like a feature to WebAssembly in general. So once you're done writing your function, it's easy. Just run npm run as build, and you're good to go. So you're going to get optimized WASM file and untouched WASM file, which obviously the optimized WASM file is for production, and untouched one is for debugging purposes. So, but how you can use it? If you have already used WebAssembly, you know that instantiating a WebAssembly WASM file, it's a bit of hassle. It takes time. But what assembly script does for us is that they introduce a loader package or a function called instantiating streaming. And what it does for us, you just need to pass your stream of WASM optimized file to this function, and that is a promise. And once it's back, you get all of those your function that you exposed or you exported, and then you get it in your main thread. So simple, one line of code. So then I have this function in my React component, factory WASM, which it just goes through the WASM services or this WASM file or which I instantiated, and then I call the function that I created, and I pass my integer to it. And once it's done, I want to set the result, right? And change my DOM. And I also, for comparison purposes, I also created the exact same function. You see, the function that I defined here right now in JavaScript code, it's similar to what I did in assembly or TypeScript. So it doesn't just have type. So I just create this function right now and want to compare, like, because there are, you may also have heard that, well, WebAssembly it's very, very fast, right? I want to compare it and see if it's really fast. And let's have a look at it. So, like I said, I want to measure it. Let's go through it. The number that I actually passed is the 10,000 Fibonacci number, right? I want to get this number, like a very big number. When I run for the first time, like, listen to me. When I run for the first time, so the WebAssembly actually executed like 7 times faster than of the JavaScript implementation. So it was fast actually for this particular use case, right? But when I run after the first time, like second time and third time, it was pretty much similar, like no difference, because the JavaScript engine actually after the first time, it also optimized itself. That's why when you run it for the second time, it's also fast. So let's have a look at this implementation. That was the WebAssembly, and that was like without WebAssembly for running the Fibonacci filter, right? You see that the difference is 7 times faster, and also there is no blocking of this animation whatsoever. So my point was here, even though assembly script is easy and you may find a lot of library and a lot of cases for your project to implement the assembly script, you may need to measure it time to time to see if it's really worth like converting to WebAssembly or not. So always measure and measure and measure. Let's go to the third option in the browser, Worklets. So Worklets, again, they are built on top of web workers. But they have some interesting characteristics. Like for instance, you have access to a very low-level part of rendering engine. You can actually render graphic or process audios, or you can also run both JavaScript and assembly for that. It's quite performant, so you have access to a very low-level pipeline of rendering. So we have 4 different types of worklet as of now: paint, animation, layout, audio. So paint worklet has pretty better support in different browsers, but the rest, like animation, layout, and audio, well, the vendors are working on it to make it be implemented in their browser so we can use these APIs. So that's why I'm just going to show you one example and one particular API, CSS Paint API, which is also known as CSS Custom Paint or Houdini's Paint Worklet. You may have heard about it, but what is this API? What does it do? Imagine that you want to actually create like a chess board or checkerboard, right? So, well, there are different ways. So if you want to use JavaScript for rendering this checkerboards, the code is going to look like this, right? And here with Worklet, I can actually render, I can paint this to the browser, into the browser myself. So I just need to register my painter and also use it. Then I can use it in my CSS. So let's have a look at it here. For instance, I want to have like a text area that the background, I want to paint this checkboard. You see that here. I'm actually, first of all, I'm checking if the CSS type and also paint worklet available in the CSS. That means I'm progressively checking for my customer if they have this functionality in their browser. So then I add my chessboard, which I actually created here. Simple. So I just need to register my painter, give a name and the function or the class. So then I can paint this chessboard. Pretty amazing. And let's have a look at it. How does it look? This is how it looks. So this is exactly the code that I created. So it's pretty fast. And but what are the like if I want to give you more examples, like very much more practical example, I can show you this example. So imagine that you can have like a barcode rendering option on your React or whatever front-end application you have. You see the animation, how smooth is this? Even though I'm repainting this this barcode, as soon as I'm writing everything in the input or changing the mode, because it runs in a different thread, so obviously it doesn't block my animation, even though I'm doing a lot of things or a lot of interaction. This is pretty amazing. This is one practical example for probably your project next time. So I see that some of you are sending some questions. I'll get back to them as soon as I'm done. Last but not least, service worker. So why I'm talking about service worker? First of all, I'm a PWA lover. I love progressive web apps. And the brain of progressive web apps are just service workers. I have a very detailed talk about an hour or so about service worker, so you can find it in my slide in this. I put the link here. But what service worker does, let's go through it quickly. Again, it's a type of web worker. You see that again, it's run different threads, so obviously. But the thing is that it doesn't have any connection to main thread. So it's not like WebAssembly or Worklets or web workers. It has been created for different purposes. And the thing is that what it does, it just intercepts all of the network requests for you, and it's perfect time for manipulating the request and respond if you need it. I'll give you some examples. But let's see how actually it works. When the request comes to your site, so technically it goes, if you have a service worker, it goes to service worker, and in your service worker, that is a perfect time you can cache your assets. And then if there is no connectivity in the service worker, you can decide like this request is coming. If there is internet, go to server or do whatever else you want to do. There are different strategies for caching. And then if it's offline, then go to cache and then get the respond and then cache respond and then send it back to the browser. Perfect. Perfect for making your web application offline. But the reason that I really want to talk about service worker is not this use case. It's another use case, particularly about manipulating the response. So how can you register a service worker? It's pretty easy. Again, you need to check if service worker is available in Navigator, which is available in most of the browsers these days, even on Safari. So then you have service worker on Navigator. You can register your service worker is a JavaScript file. It's nothing than just a JavaScript. So you register your JavaScript file and then you're good to go. So service worker will stay there forever until you change it or remove it. So before you use service worker, please read more about it if you don't know, and then use it, because there might be some traps and tricks here that you need to know before you implement. But what was the use case? Why I'm interested in service worker if I cannot use it directly in my main thread, right? This is just for intercepting requests and response. Why I'm talking about it? Because you can do many things on the fly. You literally, here is your service worker between your site and server or cache. You can do whatever you want with this request and respond. For one example, a great example was created by my friend Kenneth. So he's also one of the co-creator of PWA concepts. One example was, when you fetch something, like let's say in this example in particular, when you fetch an image, and at that time when he created this example, the image, WebP image was not supported in all browsers. So, but you know that WebP is pretty optimized and very, it has a very low size compared to other, even JPEG, right? So he wanted to use WebP, but how can you support WebP in different browsers? So, well, you want to use WebP, but they don't support, right? what he did was, like, when you request for WebP, the code is pretty self-explanatory. So he created a WASM file for some encoder and decoder of JPEG and BMP and etc. What it does, so when you request for WebP, he actually sent these requests to this decoder, and then he got back the decoded version of these blobs. And instead of a WebP responding to the browser, he was responding with another header and a different blob, which was supported by the browser. So even though some of the browser, they didn't know about .webp file, they still could show this image. This was pretty, you see, this is exactly what you need to think about it. Like, you can intercept this request, then you can manipulate it in a different way. So great. So we actually went through 4 options today: web workers, WebAssembly, and Worklets. In particular, that you can use them as a worker thread in your and communicate it with your main thread and hold off your heavy computation and execution to them. And we talked about service worker, even though you cannot use like directly service worker in the main thread, but you still can intercept requests and respond and manipulate them on the fly, which all in all brings and boosts user experience. So with that said, thank you very much. If you want to learn, if you want to grab some of these codes or example, if you want to watch it again, this is a short link for you to click and go through it. And if you want to follow me or be in touch with me, I'm also very active on Twitter with this handler on the screen, or maybe LinkedIn. So feel free to be in touch. Thank you very much for listening to me. So I'm going to go through actually the questions.
Perfect. I will just remind everybody who listens, if you have any questions, please type them in a Q&A form. If you don't know where to find them, look in the top right corner of your screen. There is possibility if you have hidden this side part at the moment. So yeah, Majid, you can.
Yes.
Maybe
the first question
you read the answer. Yeah.
Yeah. Your first question is, for what cases you would not recommend to use web workers? Well, that's a good question. I mentioned in my talk that for the assembly part, that if you're using, as for instance, assembly script, you just measure, right? This is exactly my answer to all of these solutions. If you want to use web worker for any execution of your function, well, that doesn't make sense, right? Because running actually in web worker, there is also an overhead you need to take into account. You need to spawn this, web worker and pass this message to that, and then it does something for you, and then it comes back. So there will be some time here to do all of this, right? So the cases that you would not probably use is that if you measure, first of all, if you go through this, for instance, examples and use cases that I mentioned, if you just implement something, let's say this function, like sorting function. If I want to do it in main thread, for instance, obviously it just blocks. So that's probably a good reason that I will hold it off to the different thread. But if it was like smaller, still I wanted to do it in web worker. For me, well, I needed to compare the time of execution, and like, if I do it in web worker and instantiate this and come back, does it really improve the performance or does not? If it doesn't, then you should not just use it, just simply avoid it, because although it's very good to use these tools, but you should think about it, there's also overhead. So you need to also measure before you decide what to pass to these workers. I hope I answered your question. If not, then you can send me another question. Is there any comparison of currently available WebAssembly runtime like Blazor, Rust, or whatever by size, prooflessness, etc.? There are some tools and there are some comparison tools actually. Not sure if they also compare assembly script, which was in my talk, but yes, there are some tools that they check different possibilities for WebAssembly and WASM. I can post it as soon as I find them. So I don't have it immediately in my mind, but I've seen them on GitHub under the repo. Especially if you go probably to Awesome WebAssembly, I think you will find it for sure. But I will try to find and send it to probably my Twitter later, or I can also send it to Edgar's so he can send it to you later.